Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4 because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7/4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this because we can divide top and bottom by 4. So that would be 23/7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2/7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000 but 1,000 squared, so that's another 3 zeros. You can see here that that's 1,000,000, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28, so the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them, and let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees. Because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees, because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an x and this a y and written x equals 85 and y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. Sometimes easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times to the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A. And we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. You can't multiply mixed numbers. You've got to first of all convert them into improper fractions. So how you do that is you get the big number and you times it by the bottom and add to the top. So 1 times 6 is 6, add to the top is going to be 11 over 6. 2 times 3, add to the top. So 2 times 3 is 6, add to the top is 7. Notice the denominators stay the same, so the 6 and the 3 will just stay the same. And then we're going to multiply the tops, which is 77, multiply the bottom, which is 18. Then we ask how many 18s go into 77. Well, that would be 4. And 4 lots of 18. When you subtract that away from the 77, you get 5. So it becomes 4 and 5/18 is our answer. So we're asked to solve this. And so what I'm going to do is just write it out a bit bigger and get my solving lines in. And we can see the first thing we're going to do is divide by 20 both sides to get x squared on its own. So I'll leave x squared on the left hand side and 16 on the right hand side. Then we're going to square root both sides. And yes, that will give us x equals 4, but it will also give us x equals minus 4, because minus 4 times minus 4 is also equal to 16. So our two solutions are 4 and minus 4. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, fill in the zeros. So it'd be 7, 1 and all those zeros, and then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40. Which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now, next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1600, take away 400 pi. Now, we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the centre X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that will be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So going to be x to the power of 16, and then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So here we're asked for a minus b. So in our vector we're going to do a, which at the top is 5, take away b, which at the top is 4. And we're going to do the same with the bottom, so we're going to take away the minus 2, take away the 7. 5 take away 4 is going to be 1. Minus 2 minus 7 is going to be minus 9. So our vector will be 1 at the top and minus 9 at the bottom. We know that vectors are written as the amount right at the top and the amount up we go at the bottom. So looking just at the x coordinates, we've gone from 5 to 7, so we've gone right 2. Looking at the y coordinates, we've gone from 6 down to 2, so we've actually gone down 4. So it's going to be minus 4. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17, so we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. Okay, I'm just going to do a quick grid to be able to do this question. And I'm going to put the 2x minus 11 at the top, so 2x, and we've got minus 11. And we're going to do the 3x minus 4 down the side, so 3x minus 4. And it's multiplication grid, because the two brackets are together, so 3x times 2x is 6x squared. 3x times minus 11, well that's going to be a minus, and 3 times 11 is 33 with an x. Minus 4 times 2 would be minus 8x, because it's 2x. And 2 minuses make a positive, and that would be positive 44, and we can put plus there. Because when we put them all together, we get 6x squared minus 33x minus 8x plus 44. Now you can see that these two here, the minus 33x and the minus 8x, are like terms, so we're just going to add them together, and we get 6x squared minus 41x plus 44. And so our answer is 6x squared minus 41x plus 44. So we would need to first of all factorise the quadratic on the right hand side, or on the left hand side, and we'll end up with 2 sets of brackets equals 0. And so to do that, what we do is we multiply the coefficient of the x squared and the number on its own, and we're looking for two numbers that multiply together to make that number. And so 20 times negative 6 is going to be negative 120. And we're also looking for the same two numbers to add up to the coefficient of the x. So we need the numbers to add together to make that 7. And so just thinking about it, they both need to be opposite signs because they've multiplied together to make a negative, and they're not too different. They've got a difference of 7, so it's going to be -8 and 15, I think. And that is correct. And you can write out the factors of 120 or -120 and add them all together to find out which ones add together to make 7. We're going to copy out the quadratic on the left-hand side, but this time, instead of writing +7x, we're going to write +15x -8x. And I'd recommend you always put the negative first, but I'm going to show you here what happens if you don't put the negative first. So I'm going to highlight the first 2 terms because we're going to factorise those, and we're going to factorise the second 2 terms separately. So this is going to be 5x. We can divide out both of those, so that will be 4x plus 3, and the negative needs to be on the outside, so we've got a minus there, and 8 and 6 will be -2, so that will be 4x plus 3, because -2 plus 3 is -6. The repeating bracket is going to be our second bracket, so 4x plus 3. And the bit on the outside, 5x minus 2, will be our first bracket. So 5x take away 2 will be our first bracket. Put that into our equation. And to solve this now, we get the first bracket equal to 0. So we're going to get this equal to 0. And solve it. So get our lines down. To start by adding 2 to both sides. And then we're going to divide by 5. And we can show that as a fraction just by doing 2 over 5. So our first solution is 2/5. We do exactly the same thing to the other side. So we're going to get it equal to 0. Get our lines down. And we're going to subtract 3 both sides. That'd be 4x equals -3. And we're going to divide by 4 both sides to get x equals. So x equals, that'd be -3 over 4. So our other solution is -3/4. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that, and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem, and you have to use those words, otherwise you won't get the marks. Now next I notice that we've got a set of parallel lines here, and we've got a line going through them. And so the 44 degrees there is going to be equal to this one here. And so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles. I'll put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here, and the bottom 2 angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44. And the reason is angles in a triangle add up to 180 degrees. And so 180 take away the 44 plus the 44 is 92. 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92. And again, we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. So we're going to start off by expressing this as x equals 0.4 recurring. And what we're going to do is we're going to find out what 10 times that amount is, so 10x. And the reason why we pick 10 is we want the repeating digit to be in the units column. So 4.4444. And the beautiful thing about this is if we subtract both of these sides, so we subtract both of these sides, 10x take away x is 9x. And on the right hand side we actually just delete the repeating pattern, so 4.4444 take away 0.4444 is just 4. And then if we get our solving lines in and we divide by 9 both sides, we get x equals 4 divided by 9, or 4 over 9. So looking at the graph straight away, we know that the y coordinate of point A is 0, and we're told that it's y equals tan x, and you just need to know the graph y equals tan x, and if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270, and so therefore this point will be 360 degrees. So it's going to be 360, 0. The graph for y equals sine x would start at 0, get to 1 at 90, back down to 0 at 180, then minus 1 at 270, and then 360, back to 0, and then the pattern will just repeat. So do exactly the same thing, and then end. Now, because this is minus sine of x, we're going to just reflect it in the x-axis. So instead of going up to 1, it's going to go from 0, it's going to go down to minus 1, back to 0, but then up to 1, back to 0, then down to minus 1. So it's just a complete opposite in the x-axis, just complete reflection in the x-axis. And you make sure when you're drawing it in, you make sure it's a nice curve. And really they look at the bottom to see whether it's a U shape rather than a V shape. So really just make sure you get a nice smooth curve going at the bottoms and the tops. And although it's a bit wavy, that's more than good enough to get the marks. Here we're told that y is inversely proportional to x squared, so we've got y is proportional to 1 over x squared, that's what inversely means. And we want to change that proportionality sign for an equals, and to do that we need to times the right hand side by k. K represents a constant. Next step, we're going to put in x equals 7 and y equals 137.2 to find out what k is. So 137.2 equals k over 7 squared. Well, we know 7 squared is just 49. I'm going to solve that by timesing both sides by 49. And when we do that, we find that k is equal to 6,722.8. Going to get that equation we wrote earlier, and we're just going to rewrite it, but we know what k is now. We know it's 6722.8. And we're going to rewrite that to find out what x is when y is 34.3. So we're going to substitute the 34.3 in. And there's a little trick here. If you've got the unknown at the bottom, what you can do is actually just swap these two over. And effectively what we're doing there is timesing both sides by x squared and dividing both sides by 34.3. So we've got x squared equals 6722.8 over 34.3. And then we want to solve it. So get our lines in, square root both sides. And when you square root, that fraction equals 196. Square root it, it will equal 14. So our answer is x equals 14. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. When solving simultaneous equations, when you have the equations drawn graphically, the solutions are just where the two lines cross. So we've got a solution here and a solution here. So the first solution is that x is 0 when y is minus 3, and our second solution is that x is 3 when y equals 0. So if the area of the rectangle is 10 and one of the lengths is root 75, to find the other length we do the area divided by the length given, and that will work out what the other length is. Root 75 though is something that can be simplified, so let's simplify that. And it's root 25 root 3, so it's 5 root 3. So this equals 10 over 5 root 3. Now notice top and bottom can be simplified. So that becomes 2 over root 3. And we're asked to rationalise the denominator. So we're going to times this by root 3 over root 3. And so we end up with 2 root 3 over 3. So our answer is 2 root 3 over 3. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. We're going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. You'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient, or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2, and we're going to do it from the x squared and the x term. So we're going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. That plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. and then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49 because we don't really want that 49. Close bracket, plus 5. Okay, now I'm going to expand these brackets and to have the 2 next to the x plus 7 squared. And 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already, we know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.